Just like the Wizard of Oz Scarecrow, your PC also needs a brain. And here, of course, to actually tell us all about that is going to be Mr. Wes Bryan. All right, Wes, this is one of these subjects, once again, as we start to dive into it, there's a lot more to it than just saying we need one, right?
That's right. You know, it really does form the brains of the operations, like you've made mention of. And not every processor really is going to be the same. And we have to be able to identify not only some of the characteristics of CPUs today, we have to also be able to tell things like socket types and stuff. So we're going to be looking at some of the key attributes, features of processors or central processing units here in this episode.
All right, looks like we're ready to get started. Head on over to the bench.
All right, everyone, come on over here and join me here. And yes, we're going to do a little bit of show and tell, and we're actually going to look at the operating system likewise, too. Because one of the things that is very important when we talk about processors in general is being able to identify the architecture, right? Architecture is very important. And when we say architecture, typically in today's day and age, what do we mean by that? Well, we really mean the difference between what is known as a 32-bit processor and what's known as a 64-bit processor. All right, and you might hear terms that are thrown out when we talk about 64-bit processing as x64. You might hear 32-bit processors called x86 processors, right? So what do we mean when we say x64 versus x86? Well, the term x86 actually goes back to the earlier days of Intel when we had things like 8086 based processors, and we've kind of kept that designation, but that designation for us today means that it is a 32-bit CPU architecture, which means if you think about your CPU as being the brains of processing information, it can do it in 32-bit chunks at a time. These are really considered older systems by today's day and age because why does the architecture matter? Why does a 32-bit versus a 64-bit, whether you say x86 or you say x64, why does that really matter? Well, with 32-bit processors, you have a memory limitation of 4 gigabytes, right? We say a 32-bit memory address space, and that really gives us around 4.3 billion potential memory addresses. That really just boils down to 4 gigabyte memory limitation. But in today's day and age, we have boards that support well beyond the 4 gigabyte limitation. And if you need that support, which most people kind of do today, because we're using applications that require more processing power, more RAM, then what we need to do is we need to go with a 64-bit or an x64-based system because we get past that 4 gigabyte limitation. Let me show you how you can kind of identify this inside of your operating system, Ronnie, so it's not just all theory. So what I did is I pulled up our system properties here. And if you've never pulled up the system properties, I can show you how we do that. You just right-click, if you will, on your Windows tile there and choose System. It takes you into this location right here. And what I'd like you to do is I'd like you to kind of focus in on this aspect right here. So I have an Intel Core i7. We'll talk about what all that means here in a second, but more specifically, what I want you to see is that this is an x64-based processor, which means it's 64-bit architecture. We have a 64-bit operating system on it, and you can see I have a lot more than 4 gigs of RAM that is usable. Now, let me step back and say, for some of you maybe that are wondering, can I run a 32-bit operating system on a 64-bit platform? Yes, you can. But once you install that 32-bit operating system, you have now limited the amount of memory that operating system can address. So I just kind of want to talk a little bit about that. Now, when we talk about these processors, a lot of times what we're talking about is we're talking about in things like workstations, desktops, if you will, as well as even server operating systems. But there is this push, and has been for a long time, that we have a lot of mobile devices, right? We have a lot of mobile motherboards out there, and that's where another technology comes in, and that's something known as ARM-based processing. Now, I want to mention a little bit about that too, because ARM processors have been around And I was talking to Ronnie on this one. I was actually kind of surprised. They've been around for quite a few decades now, right? But where they really gained traction and popularity is that within this last 10 years-ish, and again, I'm just throwing ballpark figures out here, and that is due to the advancement of mobile technologies, right? ARM, if you will, these were actually go back to the early days by a company called Acorn, or Acorn, if you will. I always want to say Acorn, but it's Acorn RISC machines. Today, you might hear them called advanced RISC machines, which means they're called reduced instruction set computing, which means they can reduce the complexity of the instructions that these processors are chewing up, if you will, or processing, and they get faster speeds. But the big thing with the ARM processors are they have very low power requirements. They can be passively cooled. You have them in your smartphones right now. Qualcomm is one of the biggest manufacturers, and if you're in a certification endeavor, if you're in a support endeavor, I would recommend go out to Qualcomm's website and look at some of the benefits of their ARM-based chips. They're in mobile devices, but understand that ARM doesn't restrict you to 32-bit or 64-bit, right? They have 32-bit and 64-bit varieties, but that is the big thing. x64, x86, your workstations, if you will, your laptops, your servers, ARM-based CPUs are going to be ones that we commonly, Ronnie, we find within our mobile devices today.
Yeah. Now, the other thing that we also are going to consider today in comparison to years ago is that most CPUs don't just have what we call a single core anymore. They actually have multiple cores, right?
Right, and that gets a little confusing. You're like, what do you mean? I've got a processor and it's got more than one core. What does that actually mean? Well, in the earlier days when we had just a single core, you had what is known as a single computational unit on the die of the CPU. So for instance, I have a small little CPU here. In fact, this is an Intel, I can't remember, this is an i7, I believe. Oh, this is an i5. All right, and if we look at kind of like the packaging on this, it doesn't really look like much, right? It just looks like a metal die, and then we have a printed circuit board. We'll get back into what that circuit board is actually using. So within that CPU, in the earlier days, you had one processing unit, right? And it would do all the arithmetic, all the calculations, if you will, when CPUs need to work with information. However, because CPUs are so lightning fast and we're getting smaller and smaller and smaller and smaller sizes, they said, we can increase the efficiencies of these CPUs by putting more than one processing unit on. It's like having multiple CPUs in one, but each one of these individual processing units are what are known as cores. And a multi-core processor just means that you can process more than one piece of information at one time, increasing the performance. Let me show you here. I'm going to show you inside of my Windows machine. You can actually see this. I'm going to bring up my task manager. And I want to show you where you can see some visualizations of this, right? So what I have here is I have what is known as a i7 quad-core processor, right? I have one physical socket, one CPU that is mounted to the motherboard, but inside of that inside of that CPU, we have four independent logical processing units, right? Inside of them. And collectively, they can help us to multitask a lot better. That is a multi-core processor. But be careful, Ronnie. I might just mention that you might also hear multi-processor support. That is literally more than one physical socket on a motherboard, and you typically find that in things like your server implementations or high-end workstations. That's not the same, because that's two or more physical sockets, each with an individual CPU, and then on top of that, your CPUs can have the logical cores or the physical cores within them.
Now, along with this, another word that probably people throw around a lot is the term multi-threading. It sounds like multiple cores. Is that the same?
Not really. So multi-threading is more of, we think about how software utilizes the power and the capability of a CPU. And what it is, when we talk about multi-threading, we're talking about the ability to send multiple sequential computing streams simultaneously into a CPU. All right, you might hear it also called generically simultaneous multi-threading, and there are a couple of different ways that they implement this. The most common way that has for the long time been the industry-wide multi-threading standard is Intel's hyper-threading. All right. AMD has a way that they're doing this now, but for the longest time, they didn't really support hyper-threading. They had some additional technologies that would simulate a hyper-threading, but today what they do have is what's called SMT, and that's just kind of their version generically of simultaneous multi-threading. Now, what this allows us to do, and the technology, the way the architecture was built, they realized that not all the cores within a CPU and all the registers within a CPU were even going to be used. So they said, wouldn't it be nice if we could use some of those additional registers within the CPU, and we could send information from an application into those that are not being completely utilized while simultaneously sending a piece of information into some of the other registers. Now, this is a way that you logically divide up the cores, so it's done in software. Let me show you what I mean here. So remember, we just launched up our task manager, and we've seen that there was one physical socket. There are 4 physical cores. But Ronnie, notice this, logical processors, right? So this is software's ability to take these cores and treat them as though they are double the amount of physical cores within the machine. That's Intel's hyper-threading. That is a form of a multi-threading technology. Now, you have to understand as well that applications have to be coded. You as techs do not have to worry about this, but the programmers have to make sure that the multi-threading technologies, you actually take advantage of them, because the applications don't utilize them, then those cores, those logical processors could still be sitting idle. So that's the example of multi-threading. It's a way that we can take those physical cores and in software divide them up into software-based logical cores.
Now, when we start talking about processors, a lot of them, of course, come in a chip of some form, but it doesn't mean that we can just plop them on any motherboard. We have to have a specific guide that helps us, right?
Definitely, and that's where socket types come in. And I know we've been talking about a lot of theory. Let me show you in a really close-up view, right? Every motherboard is going to have some type of connection point for your CPU, right? And we have a variety of, a couple different socket types that I want you to be aware of. This is what here is known as, if I can get that in the camera a little bit better, this right here is what is known as a PGA-based socket. This is what's called pin grid array. And more specifically, if you've never heard of this socket type, this is what's known as a ZIF socket, a zero insertion force socket. And in the early days of computing, they realized that with these CPUs getting so hot, cooling down, heating up, cooling down, that they literally could walk themselves right out of their own sockets through the expansion and contraction through something known as chip creep. So what they did is they came up with a socket that when you open it up, you can see it kind of moves a little bit. It opens the ports in the base of the socket up all the way. You mount the PGA-based socket or a CPU, and then you push this arm down, and you can kind of hear it click there. And what that does is that locks the CPU in place so that it prevents chip creep. That is one of the most common implementations for a long time in AMD-based processors, but it's not the only one that's out there. So for instance, on my computer here, I have another common one, and this one is what is known as an LGA-based socket. This is a LAN grid array. Right, the pin grid arrays, they use a series of pins, right? That's why they're called PGA, if you will. And the pins actually mount into the ZIF socket, and when you pull that armature down, that arm down, they lock those pins into place. However, the LAN grid array, the pins are actually in the socket itself, and then what you have is you have these flat electrical contacts. In fact, let's look at this Intel i5 processor that we have here. Ronnie, notice those little raised electrical contacts, how they're flat?
Right.
Those actually sit down inside of this LGA socket. And in the LGA socket, if I kind of zoom out here, you'll see there's a little cover right here. And that little cover flaps down to hold this in place, and then you pull the armature down, and it presses that cover on top of the CPU, forcing the flat little electrical contacts to make contacts with the pins inside of the LAN grid array. This is primarily what Intel has used almost since the early days of computing. Now, I do want to make mention that today, believe it or not, AMD with their higher end line of CPUs has moved away from some of the earlier PGA-based sockets, and they're using LGA sockets as well today too. One of the final socket types that I just want to mention is something that is common in mobile devices. You have what's known as BGA. BGA is called ball grid array, but that is typically when you have a CPU that is embedded into the motherboard, which means it's integrated. An integrated component fails on a motherboard, you have to replace the whole motherboard. So it's common in mobile devices as well. And let me show you. You can't really see anything, right? We have a CPU that quite literally is embedded into the PC itself, right? We're not taking this out. If we try to take that out, we're going to cause irreversible damage to the motherboard. So with BGA or ball grid array type implementations, understand that that is literally embedded into the motherboard itself versus the ones that aren't, like the LGA and the PGA. If a CPU fails, you can replace it. Embedded BGA-based CPUs, if they fail, you typically have to replace the entire motherboard.
So when it comes down to it today, most often we're actually going to end up seeing probably Intel or AMD types of CPUs and anything else that belongs to that. So what are we really looking at when we start talking about that?
Sure, Ronnie. It hasn't been unheard of for, in a certification endeavor, you're sitting that exam and they say, okay, we have this i7 processor. Which of these sockets would you potentially use? And again, they're not really trying to trick you. They just want to know, can you identify an Intel-based CPU and an Intel-based socket? Same thing with AMD. From time to time, you might have an AMD processor, and in the list will be an AMD socket that you need to be aware of and be able to identify. Now, there's a laundry list of them. I've actually put these into the show notes for you, and I've got a variety of Intel CPUs with their matching sockets. It's a list of them, everyone. You're going to have to make some flashcards. It's one of those things that I call can't stand thems because it's just sheer memorization. I have some of the CPUs for Intel, such as the i-Series, i-Core series, i9, i7, i5, and i3, and associated sockets. I do want to make mention that you should be able to identify a server-level Intel processor, and that's going to be Xeon today. And I also have our sockets for the Xeon processor too. Understand that the Xeon processor is one that allows you to perform multi-processing, multi-CPU processing, which means more than one physical socket on the motherboard. AMD, they also have a series of CPUs and sockets associated. Some of the more common ones today are the Ryzen, the Ryzen-based processors, and I also have some of their sockets that are associated with them. You'll also see other ones like Athlon. Their server equivalents today, their server-based processors are EPYC and Opteron. These are two processors that will allow multiple sockets on a single motherboard. Utilize the learner resources, make some notes, make some flashcards, be able to identify and associate certain Intel processors with their sockets, likewise with AMD, and be able to recognize some of the specifications we have when it comes to CPUs. Remember, at the end of the day, your CPU is going to be measured in its clock speed, and its clock speed is typically today measured in gigahertz, which means for a single tick of a second, a CPU can do upwards of 3 billion calculations. Keep in mind that all CPUs are not built the same because you have that second, but certain CPUs can perform more instructions and calculate more instructions within that given second as well. So remember this and be able to identify some of these facts that when it comes to the certification exam, if they put you in a scenario, you're going to be able to associate some of these features. And if you are in a support desk role and you need to make a recommendation on some of the processors and sockets that need to be available on the motherboards, you're going to be able to make those recommendations.
Thank you for watching IT Pro TV.
How do we increase the capabilities of a computer that we've bought with limited capabilities? Want to know the answer? Join us next.
You're watching IT Pro TV.
Welcome back to the show as we get started talking about the idea here of actually taking the computer system that we have and then realizing that we actually need to add more to it, and this is the right person to talk to help us out. Now, Wes, when it comes down to these types of devices, it can be a little bit confusing because I can see a bunch of components in a regular brick and mortar store and go, I think that's the one I need, but is it? So how are we going to tackle this topic?
Yeah, that's right, Ronnie. So, our computers do come with a limited set of functionality, and we can expand that functionality by bringing in something that's known as expansion cards. Maybe you've heard of this term, adapter cards, as well, kind of synonymous terms. So, what's going to be important for our episode here today is just kind of talk about why we would use expansion cards. That's more the why we would actually want to do something like that. And it's really important that if we are going to connect these cards to our motherboards, that we understand. Big surprise here, some of the specifications around some of that bus architecture. So we're going to have some stuff for you, our audience out there, to study and make some flashcards because specifications are going to be important.
All right, it sounds like a lot for us to get through, so why don't we head on over to the bench?
All right, everyone, come on over here and join me. And one of the things I absolutely love about this series is we really get to look at some of the hardware and not just have a discussion on the hardware, but I'd like to build on, the conversation that Ronnie helped us get started here. And, why is it that we would want to have expansion cards? Well, if we take a bird's eye view over here, we've got one of the motherboards that we've been using here. And the motherboards are great because they do have a certain amount of functionality that's built into them. We have our I/O panel here, and that's one of the things that, for instance, like an ATX standard motherboard standard brought in, right? That we do have integrated functionality. You can see that we have our network adapters. We've got some USB 3.2 Gen 2 connectors and series of video display connectors, like, for instance, DVI and VGA and HDMI. So when we start out, we got a lot of functionality, but there might be times when we want to expand that functionality. Or one of the great things about motherboard manufacturers out there is they can actually limit the price point of a motherboard based on limited functionality. And if they give you the ability to expand the functionality, that'll be through adding things like these adapter cards, expansion cards. So Ronnie, there's a whole slew of different cards that we have out there when it comes to expansion cards. If we kind of look, again, bird's eye view here, you can see, for instance, this is a network adapter. Now, I want you to let you know that network adapters are integrated into our motherboards. But what happens if this port, let's say, fails? All right, and maybe we can't afford to just throw this whole entire motherboard out because that port has failed. Well, if I have sockets or slots, if you will, more important, probably called slots here on the motherboard, then what I can do is I can add the functionality essentially by installing this card on the motherboard, if you will, and bring that functionality that maybe isn't there, or maybe, again, like, for instance, an embedded component, has failed. So you have things like this, right? Network cards. I got a couple of them. And again, the reason, what's the difference here? A card is a card, right? Well, I want you to look at the little copper conductors down there at the bottom, right? On this side, we have what's known as a PCIe card. We'll get to these connection types here in a second. But on this side, we have a PCI card, right? So not all cards are going to be equal, and you have to know, why would I choose one over the other? So let's talk a little bit about the connection types here. So when we talk about connection types, you have a series of bus standards that I want you to be aware of, because that's going to dictate, if you're in a certification exam and they put you in a scenario, which card will you choose? Or if you're in a support role and somebody says, hey, I've got embedded video. I've got video is integrated into my motherboard, but you know what? We need to step it up a little bit. I need more dedicated graphics, right? Well, I can actually, if I've got available connections on the motherboard, I could bring that functionality. So let's talk about those connection types. Ronnie, there's one here that's been around for a very long time, and that's the peripheral component interconnect, PCI. And I know you've seen this one before, so let's talk about that one, Ronnie. PCI. We talk about this one. It has been around for a very long time, and it might be one that you might not even see on your motherboards anymore. In fact, the motherboard that I have here doesn't even have a PCI slot. So, Ronnie, what can you tell us a little bit about some things you know with a PCI slot? Because I know you had to use these in the past as well.
Well, on older computers at one point, right, they had many of these because people would buy the basic system, and then you could expand the capabilities. So you might find out that you need better sound, or something like that. Mm-hmm. So whatever it is that you wanted to essentially turn your machine into, maybe a dedicated video adapting, or whatever it might be, video editing, or sound editing, or mixing, whatever it might be, these types of cards really can actually help you to make that computer do a lot more, especially when you have the software. Now, Wes, the issue, of course, is that it actually was limited in its speed. If I remember correctly, yeah, you have 133 megabytes per second here, and it sounds super fast during that day and age when we're actually using these. But in comparison to the things that we do today, it's probably relatively slow. So on most computers, you'll probably not find a lot of PCI slots. If you do, it's probably going to be one, and it's actually just designed for legacy or backward compatibility. That you might have that legacy Sound Blaster 16 card that's just sitting there. You go, no, I still love that thing, and you want to still plug it in.
It's funny, Ronnie says that, but I actually have one of those cards, those old Sound Blaster cards. And I want to kind of build on what Ronnie said about the limiting factor, right? Everyone out there, we've got some show notes for you. We've got some specifications. I don't want to bore you with stuff that really you need to make some flashcards and you just need to know. But one of the limiting factors that Ronnie was mentioning on PCI is the fact that it used what we know, if you've been following along in the series, is parallel communications. And anytime you have a parallel communication, you do run the risk of having crosstalk and interference. The other as well is that only one device could control the PCI bus at one point. So it's what's known as a half duplex communication, which means if I have up to 5, potentially 10, if we have 2, in the older days you could have up to 10 PCI slots. That means if I have populated every one of those slots with cards, that when one card wants to talk, every other card has to stop communicating with the motherboard and the CPU. So you could see that that would cause performance issues. And the way one of the things that they would do is they would implement something called bus mastering. It was just a way for the card to say, hey, everybody out there, stay silent. I've got stuff I need to communicate. So I do have some of this information all put in the notes, make some flashcards on it, but the successor to PCI is one that we see today, and that's something known as PCIe. PCIe, you might see it abbreviated that way. You might hear it called PCI Express, and it is the successor to a couple of standards, most namely the PCI standard. And what they did is they moved away, and in fact, let's take a bird's eye view. You can see a couple of these. We have a couple of these slots right here on the motherboard. This is a PCI slot, and these two smaller ones here, you can see, are also PCI slots. So what is the difference between PCI and PCIe? Well, PCIe, the special interest group that oversees PCI, they said, let's get away from the parallel communications, much like we did with our storage devices like parallel ATA and serial ATA. Let's go with a serial communication, because a serial communication doesn't have that same problem when parallel communications of a shared bus topology, and believe it or not, it forms kind of like these little point-to-point connections across your motherboard. It is also a full duplex communication. So unlike PCI, where it's one device talks, everything listens, every card that is in a PCIe slot can have a two-way communication simultaneously. That's a full duplex communication. There are a variety of specifications that I want you to be aware of. The big ones that I can help you out for the theory-wise is, and if we look at our motherboard here, is that you're going to see some different shapes, sizes of these cards. All right, and that is due to how they have basically created the architecture. The architecture for PCIe works on multiple lane links, if you will, as they call it, right? So you might see something like this one called a 16 or an X16 card. This one right here is an X1, and this one is an X1. What does that mean? Well, that means you have 16 individual links or lanes in a PCIe 16-lane card, and all 16 lanes can send information at the same time. So a massive amount of bandwidth can go over these over this bus architecture. But you do have to pay attention, because the shape of the card, for instance, this is a PCIe 4-lane card. Notice that it's not going to fit in our 1-lane card. This is a PCIe 1-lane card, and notice that the contacts are a little bit different. So I want you to be aware of that. Now, how do we figure out what the bandwidth of a PCIe card is? Well, you have, I think we're up to 6 versions today. I think PCIe 6.0 is they're still working on. But it is an easy way to tell. Each revision, a single lane tells you what the bandwidth of that lane is, and then it's just a multiplier of that single bandwidth, right? So if we have a 16-lane card, I'll give you an example. In version 1.0 of PCIe, a single one-lane card would produce 250 megabyte transfer speeds. That is almost double of what PCI was at its best, and it's a full duplex communication. So how would I figure out a 16-lane card? Take that 250 megabytes and multiply it by 16, and you're going to get 4 gigabyte transfer speeds in a 16-lane card. I don't expect you to remember all of that in a single episode. Everyone out there, we've made it a little bit easier. I've got all of the revisions. I've got the single lane and the 16-lane speeds here to make it easier, make you some flashcards. But the PCI or the PCI Express bus is the way we are going today.
So what we're really trying to make sure that people understand, especially if you're an IT professional working on motherboards, right, is take a look at the motherboard itself, find out what the standard is going to be, and that way if you do need to purchase, let's say, a video graphics card, right, you know that there are actually some that will actually be of different specifications and realize which one will give you the max bang for the buck. Now, Wes, what if I actually say, hey, I've got that latest edition that you were talking about, that PCI 6, I think is what you were saying. What if I have that on the motherboard, but the cards that I'm seeing are PCI 4? Is that okay?
It's okay, and I'm glad you put you brought that to light here, because they are backwards compatible. It's just one of those things where if we put a newer technology on an older interface, it's going to run at that older interface's speed. Right. And that might be okay for everybody out there. So do what Ronnie says. Pay attention to what the specifications and the standards are at the end of the day. If you're in a certification exam, yes, you need to know these speeds. If you're in a support role, you need to know the architecture so that you can make the right recommendation and saying, hey, you probably won't get the full utilization of that 16-lane card. You might be able to go ahead and go with an 8-lane card, because that's what this motherboard is going to give you the best bang for your buck. So again, knowing the standards is going to be important.
Now, that also leads us to a different kind of question with the same thought here, Wes. I believe that I could take like a 4-lane and even put it into a 16-lane slot if I chose to. I'm just not going to get the full benefit of that slot.
Ronnie, I'm glad you said that. Let's go ahead and show you exactly what Ronnie's talking about here. So remember I said that we have a 16-lane card here, and I told you that this was a 1-lane card, right? So technically, I should be installing this right like that, right? There's your expansion card. But what you'll notice is what Ronnie said, I can actually install that in a 16-lane slot, right? But the thing is, I'm just not going to use all the capabilities of those multi-lane striping, essentially, is what PCIe does. And I want to show you this in relative to our computer cases, because you're seeing the motherboard here, but I want to show you, so we've got our computer that we've been using throughout the series here, and I want you to look at the back. See, these are blanking plates. And when I need to expand the functionality, what I'm going to do is I'm going to take the blanking plate out, and I'm going to find the aligned bus, or in this case probably a PCIe bus, and I'm going to install that card in that slot. So that's where you see, talking about expansions, we can expand the functionality. Now keep in mind, this case here has 4 expansion slots. That doesn't mean the motherboard has the 4 expansion slots to support it. So again, your case might have more than your motherboard has, or maybe even vice versa. You might have more support on your motherboard than you do maybe a 2-slot case, right? So pay attention to your case. Like we talk about form factors in general, it's going to be important to make sure that you have the right amount of room in the case to support being able to expand that functionality.
Now, Wes, we have to talk about a little bit of an older type of bus as well. So, if I'm actually saying that right, let's talk about AGP for a moment, too.
Yeah, and sure. And you know what, Ronnie? Let's take just a couple of seconds to talk about that term bus, because I keep throwing it around there, and I apologize to you all ahead of time here. What is a bus? A bus essentially is the highways, right? In fact, let me go ahead and turn over this motherboard here, and let's look at it from a bird's eye view. And I know this is reflective, but I want you to see the little copper, and they don't look copper because they've been covered with an electro or an anti-static coating doing here. But I want you to see, those are not fingerprints. All those little traces that you see are electrical conductors that are like data highways, and our data passes between multiple points on the motherboard via these connections. So I figured I'd take a second here and just address what a bus is, right? Those are the pathways, and these are the technologies. Now, Ronnie mentioned one that's been kind of around for a very long time, and really PCIe became the successor, and we don't really see too much of anymore, and that's Intel's Accelerated Graphics Port, AGP. You're never shy of acronyms here. But AGP was an earlier standard that Intel put out, and they put that out as a way to kind of combat some of the limitations of PCI. Essentially, it's a dedicated single PCI slot is what it is, but I don't want you to confuse it, but that's what the architecture was built on. And they put it close to the CPU so that you could have advanced graphics. Its legacy, it was largely replaced by PCIe today, but I did want you to know that it's available.
Yeah, let's kind of explain that a little bit. The idea of that dedicated graphics bus is what we're really talking about.
It's exactly what it is, yes.
So it's still kind of like PCI, so the original one that Wes was talking about here. But remember what Wes told us about the idea of bus mastering, right? We have multiple devices on PCI. That means they have to share that bandwidth or that highway that we're talking about. Well, the very fact is, as graphics were getting better and faster, better, more colors, whatever we want to say. The problem is when we put that onto that PCI bus, it would be competing for things like your modem. I hate to say that term, but it would be competing for those lanes, like things that were actually much slower, which then slowed down those graphics. So motherboard manufacturers said we need a dedicated bus, in other words, their own traces that will give them access to the CPU without having to compete with all those other things. But with PCIe, that changed it because we have individual lanes that we can actually use. So it really kind of ended up dating its own technology here, where it didn't need that dedication anymore because it was all built into the PCI standard. PCIe standard.
Yeah, definitely. As graphics became more demanding, resource demanding, PCI just would not fit the bill for those demands. One of the last ones I want to mention is another legacy option, and again, I put it in here just for sake of completeness when it comes to certification or support, and that's PCI-X. When we talk about PCI-X, that was PCI extended. PCI had in its architecture a 32-bit implementation as well as a 64-bit implementation. The 64-bit implementation wasn't widely adopted because they said, you know what, let's take a single dedicated PCI bus, kind of like Ronnie was mentioning with AGP, and let's put a 64-bit pathway across the top of it. That's PCI-X, if you will. It's Peripheral Component Interconnect Extended. And they were trying to extend the lifespan of it by bringing 64-bit processing across this bus, if you will. The problem is it was never widely adopted, and it was a very expensive implementation that you really only seen in a handful of servers. And like we said, PCIe came along, and it kind of took those two earlier bus architectures and kind of put them by the wayside, and now they're more archaic today. Everyone out there, keep in mind some of the standards that we've talked about, the reason and the purpose for our expansion cards. If you're in a certification exam, I would make some flashcards with those specifications. If you were in a help desk role, I would definitely know some of the bus architecture so that if you have to make a recommendation to your end users on which card to use, you're going to be able to make the right choice.
Thank you for watching IT Pro TV.
We need power for our PCs, but do we need a flux capacitor? What do I mean by that? Find out more next.
You're watching IT Pro TV.
Everybody wants more power for the computers, but up to the flux capacitor level? Maybe not so much. But the only guy that can really tell us is this guy right here, Mr. Wes Bryan. All right, Wes, when it comes down to it, every computer needs power. That should be the end of our show, right?
Well, you would think so. And that's it. Scene, everybody. No, what we want to do is we want to discuss some of the attributes of our power supplies, talk a little bit about some of the voltages that you can see, and then we want to be able to identify some of the connectors for our power supplies so that if you're put into a scenario on the exam, or maybe you're put into a situation where you're supporting end users, you're going to be able to make the right decisions.
All right, sounds like a lot for us to discuss. Why don't we head on over to the bench?
All right, everyone, come on over here and join me. This is going to be no exception to the rule in our series here. We're going to do a little bit of show and tell. And power supplies. You know, when it comes to a power supply, these might be obvious. They're what provides the power to our components. But it is important to understand a little bit about some of the characteristics of the power supply if you are going to be supporting this. Now, I want you to remember that if you are building a PC, you have three different form factors that must match, right? One of the form factors that must match is your motherboard, as well as your power supply, and then finally your case at the end of the day. And why is that? Well, the standardizations around the form factors actually define, for instance, what their main power connector is, and that's very important. But let's talk a little bit more about just the overall, what is the power supply doing for us, Ronnie? Ronnie, I know you're very aware of this, but do our computers, do really any computer circuitry do well with fluctuations in current?
No, they do not. They are really bad with that, and components can break if we actually have the fluctuations in power that you're talking about.
Most definitely, right? And what do we power most of our power with, right? It's going to be alternating current. Well, computer circuitry does not do like Ronnie said very well with any fluctuations in the current. So we power our computer circuitry with direct current, and that's one of the big things that a power supply allows us to do. We can do input voltages of 110, 115, depending on how what you're currently looking at the standard here in the United States and the European nations. You can see things like 220, right? That's the input voltage. But the input voltage coming in to the power supply, if you will, via our connector right here, this is going to be the AC that comes in, and then what happens is our power supply converts that into direct current, and that powers our components. But we do a little bit more than just the converting it to direct current. We also need lower voltages for a lot of our components within our systems, and that's why it's important to understand what some of the output voltages are. And I know this might be, let's zoom in a little bit here, maybe we can see it a little better. You can see some of those voltages. We have 3.3, 5 volts, and 12 volts. These are the main voltages that you find within your systems today. So what your power supply is doing in combination, and let me bring our motherboard over here, in combination with these voltage regulator modules that are built into the motherboard, is it actually steps the voltages down to the appropriate levels for what we need to power our computer circuitry, right? And you can see a series of capacitors right here, and that's all part of a voltage regulation modulation that happens inside of your power supplies. So it is important. Remember, converting AC to DC and then doing voltage regulation and stepping those voltages down to the 3.3, the 5 volts, and the 12 volts that our components operate on.
Now, Wes, you mentioned that because there's different power supplies depending on where you are, in different countries. Does that mean we need to actually buy different power supplies if we go from, let's say, here over to the UK?
No, and that's one of the great things, Ronnie. Now, this one right here, you're not going to see anywhere on this power supply. If I kind of turn this power supply all the way over, we don't really have any switches really at all. There's no switches here. So how does my power supply, or this power supply in this case, how does it know that we're connected to a 110 or a 115 circuit or a 22 or a 220 circuit? Well, it does that. There's something known as auto switching. This is an auto switching power supply, which means it can detect what the voltage is that it's connected to, and it can make the adjustments appropriately. However, you do have power supplies that you will see on the back of the power supply, a little red switch. And this is a fixed input power supply, because what that does, it can still work in both geographical regions. It just means you have to manually flip the switch. So let's talk about that real quick so we understand that if I flip this to a 220 circuit and I put it on a 115 circuit, I'm going to be grossly underpowering my system, and that's going to cause system instabilities. However, if I switch this to a 115 circuit and I connect it to a 220 outlet, I'm going to fry the power supply and all the components there. So it is important. It is important today to know that a lot of our power supplies, they're auto switching. They know, oh, that's 115. I know what I'm connected to, and they make that transition internally.
Yeah, now as far as I can remember, that little red switch has been there for those power supplies forever, for those that aren't auto switching that are actually fixed.
Yeah.
So I would look for that. If you're not sure, just remember, you already should know what country you're in, but just kind of remember that that switch may be something that is crucial before you take, let's say, a used computer and plug it into whatever wall outlet that you're in, that it is set on the proper supply for the voltage or the wattage that you need to.
Sure, and another characteristic of power supplies could be a modular power supply. Notice that I actually got one of this power supply's plugs in my hand. It's not actually plugged into the power supply. That's what's known as a modular power supply. Sometimes what you'll see is a rat's nest coming off the end of a big thing of spaghetti coming off the end, out of a little port in the back of the power supply, and there's nothing you can do. You cannot connect it or disconnect it. This is what's known as a modular power supply because, as you can see, I can connect and I can disconnect for what it is that I'm trying to power. And while we're here, let me go ahead and show you again the power, the voltage ratings. Notice the output voltage, right? The output voltage lets us know that here we have that 3.3, the 5 volts down here, 12 volts as well too. You also have a wattage rating as well too. Notice that this is a kilowatt power supply. Yes, Ronnie's going to give me some hard time here because when I decided that I needed a power supply, I needed to put one in a machine that would dim the lights 2 blocks over. So you can see also they have an efficiency rating as well. You can see this is an 80 plus silver. You might have some that are gold, and that's just how efficient the power supply is in powering our components. So that's a modular power supply. Those are some of the output voltages and a little bit about the wattage rating. Ronnie, you and I have worked together in a lot of this type of help desk, training for a long time. What would you suggest if somebody needed to figure out what wattage do I actually need for my components? More importantly, do you think it would be better to have more or less?
It's probably better to have more if you're replacing one than to actually have less. Now, of course, the ideal, right, is if the computer system is working at the at the power supply it's working at, getting a replacement that's identical is probably going to be your best bet. But when you start adding in additional components, especially things like video graphics cards, anything that makes it a more dedicated machine, you need to add that into your consideration to ensure that you give enough wattage, to those additional components. Because if you don't, what you may end up experiencing, of course, is not only slow the operation of the computer being slow, but you may actually experience like intermittent things that can also happen, or just the very fact that you've drained so much power that the system just reboots after a while too.
It does, Ronnie, and I tell you, you mentioned that. I've actually experienced that because what I've done is I said, okay, and I've taken all the wattage requirements, right, and say, okay, well, it says the motherboard requires this amount of wattage, this video card needs this amount of wattage, added all that up, and I bought a 500-watt power supply, and I thought, yeah, that's going to be good for what I needed, until I brought up a video software that really demanded the performance of that video card, and it did exactly what Ronnie said, froze, crash, reboots. It doesn't mean that the card's bad, and it doesn't mean that the motherboard's bad, but it does mean that you have to reconsider some of your power requirements for your overall system. So that's a little bit about our power supplies, but I do want to talk briefly and help you to identify some of the connectors that we have here. And remember, one of the things we talked about is the standardization. We talk about the ATX standard. Why is that so important to have those match? Well, we have a couple of different types of connectors, and as the ATX standard has progressed through the years, we started out with the original 20-pin connector. Then what happened is when the Pentium 4 processor came in, they said, whoa, wait a second here. We need the 20-pin connector, but then we also need one of, if I could find one, right here. This is a power. I got to make sure it's not a PCIe connector. But we also need a 4-pin connector right here for the Pentium 4 processor for the CPU. Now, as the standard progressed, the PCIe bus came along, and it's very power hungry, so this 20-pin connector would no longer suffice the power that we needed on our motherboard. So they came out with what is known as the 24-pin standard. That 24-pin standard is what you see on ATX form factors right here today. Now, if you do not have a 20 plus 4, which is what this is, or a solid 24-pin connector, Well, that's okay. They make these for backwards compatibility. This could be used in a 20-pin connector. We could put the extra 4-pin connector on here and make it a 24-pin connector. The other thing that you could potentially do is you could get what's known as a 20 to 24-pin adapter. That is a possibility. Ronnie and I were talking about this prior to going into this episode. I wouldn't recommend that. It is a potential. But if you, as students of technology, are doing your due diligence in what you are supporting and building, you should never run into the problem where you need that adapter unless you're supporting legacy-based systems. So I want you to be aware of that. So that's the main power connector. We have a series of other connectors here too that you should be aware of. There is your 15-pin serial ATA blade connector that I want you to be aware of too. There's two different variants of this. Variations. There is a 6-pin PCIe connector, but there's also the ability to put this together and make it an 8-pin PCIe connector, depending on your power needs. There are two different types of CPU connectors that we could use today. You could use the 4-pin P4 connector or what's known as a P8 connector. And this is one of the most common connector types. And this one, I really like this, Ronnie, because I can use this for all different types of backwards compatibility. I can put two of these together, and then I could plug those in to and it should be on here, closer to the CPU, into the 8-pin connector that you see right there that will power this CPU. This is a Ryzen processor, and it requires one of those 8-pin power connectors. So those are some of the connectors that I would be aware of. Some of the older connectors that I don't have on this power supply that I would be aware of. There are more legacy connectors. For instance, there's a 4-pin Berg connector that would have been used for floppy disk drives. There's also Molex connectors, and Molex connectors would be used for things like old SCSI drives, old parallel ATA drives, and more importantly today, we still use them. We can use them, and we can daisy chain system fans to them too. So also know the Molex connector. There are a variety of considerations when it comes to making the right choice in power supplies, and what we've given you is some examples and specifications so that if you are sitting a certification exam and you come across a scenario, you'll be able to make the right choice, but also that you'll be able to make the right choice in support desk. As a little disclaimer right here towards the end, I want you to remember that a power supply, if it fails, should always be replaced. Do not open a power supply. You all can never be replaced. You all are ones in billions, and we don't want to see you get hurt. If these devices fail, and you are not a trained electrician working for somebody like Silverstone, never open these. Always replace them. You can never be replaced. If you can do some of this stuff, you will be doing very well for a certification exam and your support endeavors.
Thank you for watching IT Pro TV.
Printer configurations. It can drive an IT professional crazy. Find out what I mean next.
You're watching IT Pro TV.
Welcome, everyone. We are talking about, well, my particular nemesis in IT, which is going to be printers. And when we start talking about that, this is the one thing that will drive people a bit mad, is when they go and hit print on your work network and it doesn't print, or it prints to the other printer instead of the one that they thought it was going to. But here's the man that can help us out. So Wes, when it comes down to printer configurations, where are we going to begin?
So we're going to take a look at the Windows 10 interface, and we're going to look at some just basic things that you can do around printer configuration. Because remember, at the end of the day, if everything goes wrong in the network, at least if your printer's working, you can print your resume on the way out the door.
That is absolutely true. But the good thing is we're actually going to learn how to hopefully help people out here.
That's right.
And that means you need to head on over to the bench.
All right, everyone, come on over here now. Joking aside, printers, they are one of the, kind of like email, it's one of the most common things that we deal with almost on a day-to-day basis. And if you're in IT, we joke around because, well, it is something that can be very challenging. And I got to give kudos to Ronnie. I do remember this in a former endeavor where we worked at the same company. We had myself, we had 2 or 3 other IT techs looking at this printer. Ronnie was the only one in the building that could get this printer working, so he ultimately became the life support for that printer for the rest of its life until we finally got rid of it. But it is one of those things that it just goes to show you that even with a lot of people looking at certain configurations and how to get maybe a print server online, that if you have a common place to start, you know some of the basic settings, it really sets you off on the right foot in this industry. And whether you're going to sit a certification exam or whether you're going to even be into support desk. So we're going to talk about some of the basic things, right? Even when it comes down to the unboxing of a printer, right? If you're unboxing any piece of equipment, you should unbox it carefully. Pay attention to all the stuff that's in the box. A lot of times you'll even have little driver cartridges today that are included with your printer. Gone are the days that you, well, I can't say completely gone are the days because then I'm going to put a hex on the whole thing, but where you would have to go out to the internet, potentially find the driver, and hopefully it would work. They've gotten a lot better today, but you definitely also have to be mindful of the setup location. Where you're going to set up your printer is really contingent on how you're going to connect to it, right? I would say probably you have to be mindful of that, right?
Yeah, when it comes down to just a lot of different things, putting that setting where it actually needs to be is key, because if people can't even find their printer, they're actually going to be in trouble as well. Now, the other thing, of course, is on the configuration side of it, people may not be able to identify the right printer. So there's actually a lot of different things we can actually talk about there, even including the connectivity issues, right?
Sure, right. So let's start right there. Let's talk about printer connectivity in general. Like, how do we connect to these devices? Well, there is the tethered approach. And the tethered approach is where you have your USB cable, typically a Type A on one side and the full-size Type B on the other. And the Type A goes just like any other most common USB port into the side of the laptop if you have it, into the workstation, and then Type B goes into the back of the printer. Now, keep in mind, when that happens, that you have a workstation now associated with that printer, and if that workstation's offline, then what we'll talk about coming up, printer sharing might not happen. All right. Another common, two of the probably the more common methods today we have are wired connections, and I do not mean the USB wired connection, but I'm talking a wired network connection, and more specifically Ethernet. Ethernet cables, we can connect our printers today because our printers are now self-sufficient devices with their own computing systems and RAM and storage devices on them and lots of other stuff. They are self-sufficient devices that when you plug them into the network, they will do like all of your other devices. They'll call out to the network and say, hey, can I have an IP address? And now they become a networked device within your network to be able to share. Another common one that is really the same thing, but the connectivity medium is different, is wireless, right? We can also have wireless printers out there as well. And those are very common in any kind of location where physical cable is limited. You might even see them in home environments too. So those are the three that I really want you to, when it comes to any kind of printer configuration, it starts with how do we connect to those devices. And remember, we have USB typically is a common one, but that does come with a certain limitation that if that workstation is turned off that it's connected to, we can't really share the printer. But then we have other more easier methods of sharing printers out with the rest of the network, and that's through a wired Ethernet connection or a wireless network connection as well.
Yeah, a lot of the things that we also have to consider when it comes down to different printers is that it doesn't happen to show up automatically with the operating system that you're using. In that sense, we have to identify a couple of different drivers. Now, when I actually tried to do this one time where it didn't show up automatically through the operating system, Wes, I came to the list where I actually found that printer, and it gave me 2 different types of printers out there. One was like PCL and the other one was PostScript. Can you help us out with those?
Sure. So those are They do have some differences, right? When it comes down to it, they're basically print drivers, right? It's what, and if you think about a driver, right? A driver is a piece of software that allows us, our operating system, to communicate with the hardware, right? That's why when you plug in a USB device, at any point you'll see Windows will flash a little preparing your device. What's it doing? Well, it's actually reaching down in Windows and saying, hey, I've got a little piece of software, a driver. I'm going to go ahead and install it, and then Windows can help you talk to that device. Well, printers are the same way. All right, and the first one you mentioned there, PCL, that's printer control language. It's probably got one of the widest operating system support in the world, minus Mac. Mac, it's not really supported in most Mac environments. That doesn't mean that you can't print to that a printer, but it just means that we have to keep in mind some of the limitations. On the other hand, there's PostScript. All right, and the PostScript is one that is another common printing language, and it is heavily used in a Mac environment. Now, here's a couple different pieces about those two. PCL, or printer control language, is device dependent. And what does that mean? Well, that means you can have, let's say, two different devices that are both using the PCL driver, and they could print completely different outputs. Why? Because that's now associated with a specific device. The PostScript is device independent. All right, so that means you're going to get more of a common printing output across a variety of devices. Let me show you here. I'm actually connected over the network. So back to those device setup connections that we were talking about, Ronnie. This is one that's actually connected to the network via a wired Ethernet connection, right? The wired Ethernet connection here, if you will, if we go to the configuration page, and these web pages don't refresh really fast, if you will, so just bear with me if you could. We can actually see some signs of PCL, and we've got our PostScript, right? So I can see that this printer actually has both of those drivers in it, which is in a environment where you're supporting both Windows and Mac, that's not uncommon, right, to see. So I definitely want you to be at least aware of those drivers. Now, there are some configuration settings that we could do potentially here too. And one of the first ones I want to talk about is what's called duplexing. Now, if I'm going to go ahead and I'm going to scroll all the way down, and you can see that this machine has a duplexing unit, all right? What does duplexing mean for us? Well, duplexing assembly essentially allows you to print to both sides of the paper. That's what duplexing means. And if you don't have a duplexing assembly, that means you're only going to print to one side. And if you need to print to the other side, you're going to have to wait till the output comes through and then reverse the paper. It's kind of a pain, right? And then put it back through the printer and print the other side, right? Well, if you have a duplexing assembly, you don't have to worry about that. And a lot of times when you have the more expensive office-based printers, they have these duplexing assemblies built into them. Definitely want you to keep that in mind likewise too. Now, let me back out of this here because I want to kind of look generically at some of the Windows settings, and I've got a couple of printers that I've associated with my laptop here. Let's get down into the settings. So I'm right-clicking on our Windows icon here. I'm going to choose Settings, and then in Devices, if you could follow along with me here, and then Printers and Scanners. Now, I have a variety of printers and scanners that are already available to my machine. Now, a couple of them are what we call virtual printers, right? They don't actually print to a physical device, right? A physical, tangible device that we can see. They still print to a printer, but it's inside of the operating system. So for instance, Microsoft's print to PDF, right? It says take this file that you see and output it to a PDF. That's a virtual printer, right? So I'm not worried too much about these, but here's two that we use. Here's our Edutainer HP LaserJet that's out on our floor, and we've got another one, a color LaserJet, that is on another location within our building. That's another reason Ronnie said you got to be careful because you send a print job to a printer, you have to make sure that you have the right printer, because I've done that before and I can't find where the heck I sent that print job to. So you also want to be in mind of what your default printer is. And when you print a document, you can typically find out what the default printer is. Let me minimize these for a second here. And we're going to print this little test page here. And, it's trying to save it to, I'm going to try that one more time here. And let's see if we can do a print. That's what I was looking for here too. All right. you will see when it is the default printer. You can let Windows configure this, or you can set printers. You can set things like preferences here as well. I want to get into a few more of the settings because the printing preferences for here are a little bit limited. I can set things like the quality here. They call out orientation as well. I would know the difference between the portrait and landscape. These are also settings that you should be aware of and what they do. You can go into advanced, and when you go into advanced, you have the ability to set things like quality. You can see what the paper output is. Is it letter? What size media are you printing out to? What type of media are you printing out to? That's also available in things like tray options too, because remember that printers can have multiple trays. And in some businesses, like for instance, the one that we have on another location within the office has 2 trays, but it's not. They're not using it right now for 2 different media types. It just says when one empties, go ahead and fail over to the bottom one and keep printing, right? So you don't have to stop the printing while somebody can refill the other tray that is empty. But you can also say, all right, well, we're going to do regular printer paper on one, and maybe we're going to do transparencies on the other one for whatever reason. So you can also have multiple media types too. So that's important as well, likewise. Now, those are really a lot of the settings that you should be aware of, but let me show you what it looks like when we get back into our devices and printers. Let me bring that back up. So if I take any printer, I'm just going to take our Edutainer's HP LaserJet here, and I choose Manage, I get the ability to do a little bit more than what we see just by our shortcut of Control P to print something, right? I have the printer properties here, and now we notice that we can get a little bit more information about it, right? Is this a color printer? No, we don't have color. Is it double-sided? Now here is a little bit of that tricky verbiage, right? Double-sided. What does that mean? Duplex, duplexing assembly. Associate that in your mind with double-sided printing. If it has a duplexing assembly built into the machine, you don't have to reverse any paper manually yourself. It will do it internally. But you can see right here that it says double-sided. No, that means it does not have a duplexing assembly, and that's going to be important at the end of the day. All right. It shows you what the speed is. We can set things like, for instance, sharing. And Ronnie, I know I'm kind of jumping out of order here, but we're right here. I figure I'll go ahead and just talk about sharing right here. I can share this printer out. Now, I don't want to double share this printer, so I'm not going to complete this because this is already a shared printer. It's how I found it on our networks. But you can see that I could share this printer out and make it available to everybody else on the network. Like I said, that's already been done, but here's where the settings would be if you needed to do that. All right, let me go ahead and just kind of cancel out of that, and let's just look at one more thing. All right, we got our basic ports here. We also have some other things like availability settings that we could do. We could do color management potentially, and even set things like NTFS-based settings permissions over it. And again, that's more of a Windows-specific thing when we talk about NTFS. So Ronnie, those are some of the configuration settings I would be aware of. I would be aware of what the term duplex means. Know what orientation means, landscape versus portrait, right? Which is, how's the paper going to be arranged when it's displayed? Tray settings. Remember that when you choose tray settings, you might say that tray 1 is for certain type of media and tray 2 is for another type of media. You could have 3 trays. You could have multiple trays. And again, that's going to be really contingent on a vendor-specific setting and how it's implemented within your organization. And then finally, you can also set things like the quality as well, too.
Now, Wes, along with that, are there any security settings we have to actually take a look at?
Oh, sure. And there's tons of them as well, too. In fact, that's why I love, I'm connected to the web interface of one of the HP printers that are on our network right now. And that's what you're seeing here when I'm looking at when we looked at the duplexing. In fact, if we look here, we can kind of see that here, the paper options and tray options that I was mentioning, you can kind of see those right here. But Ronnie, you asked something that's very, very important, and I love the fact that they have security right here where we can see it. Yes, you can do a lot of different things, right? For instance, we could have a control panel password that says, hey, you want to get to the on-screen display? You better type a password. But when they talk about things like user authentication, when you share a printer out, it is a shared resource within your network, and you can use access control methods to define who could print to that printer and when you could print to that printer. Let me give you an example. In a former training endeavor that Ronnie and I were at, it wasn't uncommon for an instructor in those days to have to print out large instructor manuals, right? Well, we had an unsung rule. It was sung, but after a while, everybody just kind of knew. You do not start printing that document out right prior to 8 o'clock in the morning when everybody's coming to work. Why? Because you have people there, you have accountants, you have salespeople, and they're printing out important documents that the business needs to operate, and it's its lifeblood. Well, they don't want to have to sit there and wait while 900 pages get printed. So one of the things that you might do is you might do blocking of times, or you might have somebody that has to require a user password to even be able to send a print job. The other thing they have is what's known as secure print, and I really like this. Secure print's nice because what that means is that if they implement secure print, then what the person does is when they send the print to the print queue, they type in a password, and it sends it to the print queue. But it holds it in the print queue. And here's where I really like this, Ronnie, because if it's an ultra-sensitive document, which in today's day with privacy, everything is sensitive, right? You do not just leave sensitive documents printed on the printer waiting for you to come over there and get them. So you've entered your password, you've sent the printer to the print queue, now you're at the printer, and you want to print that print job. Well, now you have to enter the same password you did when you sent the print job to the printer in order to complete the print job. Really, really cool. It's a secure print, secure prints, if you will. You can see there's other things that we can do, like disk encryption. This one, you can see right there, it says it can't be encrypted. They can encrypt the jobs, because remember, you're sending potentially sensitive information over to that printer. The other thing we can use is things like badging. You can use your audit logs. Now keep in mind, audit logs is to track what's already been done. So you don't want to use that as your first line of security. Big thing more than anything else is access control with share permissions and user authentication. That's going to be something that is very, very important today.
Now, Wes, along with that, even though printing is kind of the primary thing we've been talking about, we do have devices that will also allow us to go ahead and scan, right? And flatbed scanners too.
Yeah, absolutely. And there's a couple different types that they call out, right, Ronnie? They call out what's known as a flatbed scanner, and they call out what's known as an auto document feeder, all right? And they actually kind of put them right there on the same line. I've separated them out. Let's talk about the differences, right? A flatbed scanner, you've seen it where it's got a glass bed on it, and it's got some kind of scanning assembly. It's typically got some stepper motors, and it moves the light that does the scanning back and forth, right? Well, the automatic document feeder, ADF, if you will, you have enough acronyms out there, does the same thing. So what's the difference, right? Well, in these multi-function devices, right, MFDs, where they do printing, they do scanning, they do faxing, if you will, scan to fax, right? All multiple functionalities. A flatbed scanner, what it does is it scans a document and it creates a file. That's just one side. If you need to scan the other side, well, you turn it over, you scan that side, and that creates a second file. And then you put the next piece of paper on and the next piece, and each piece of paper and each scan becomes its own individual file. Well, when you get these better ones that have the ADFs, the automatic document feeder on there, I can take a stack of paper and put it on the side of the printer and push print, and it pulls the whole, let's say, 10 pages through automatically. And those 10 pages now become 10 images in a single document, right? So if I needed to do something, Ronnie's like, all right, man, you've got that proposal for me, all right? I need you to do me a favor. You've got two proposals. I could scan them and send them to Ronnie on a flatbed scanner. If I do that, he's got two documents now that are separated, right? If I do an automat or ADF, automatic document feeder, I could put that same file, right, or the same scanned documents into a single file. Right now we've got a PDF that has 2 pages within it. And that's really one of the benefits of it, the fact that you can scan multiple documents into a single file. You can also do double-sided scanning as well versus the earlier flatbed scanners. So I would know about that too. And I kind of mentioned print sharing, and I showed you where you could actually share that out. Keep in mind that you're doing that, if you're doing that in a small environment, you might share one printer, maybe share two printers, right? But if you're in a very large organization where you have tens, maybe hundreds of printers across an entire, maybe a campus, if you will, an enterprise organization, chances are you're not going to want to do individual sharing of all those printers. What you're going to want to do is you're going to want to connect them to a print server, and you're going to want to centrally manage that. And that's really what the print server does. The print server allows you to manage multiple printers in a single location. So rather than me having to connect to each individual printer and manage its properties, I can go to one computer, I could connect to the print server, and I can see all the printers that are within my networks. I can manage their drivers, upload drivers to the print servers. I could deploy the printers. I can bring them offline. I can see what the current print queue is for every one of the printers should I need to, right? Again, rather than having to tackle it on an individual basis. And at the end of the day, Ronnie, that brings you that centralized administration that eases the burden, eases that the minutiae of having to do this on a one-by-one basis. We can do it once in a single location to multiple printers at the end of the day, making your job a little bit easier. These are some of the configurations that I would be able to identify if you're in a certification endeavor, and if you haven't seen these and you're in a support role, it's just going to make you a lot better in supporting those end users.
Did you know that there, of course, are multiple types of printers that you're going to have to support as an IT professional? Not exactly sure? Well, find out more next.
You're watching IT Pro TV.
Welcome back to the show. That's right, we are diving into the realm of printers. And as an IT professional, it's not just enough to say, it doesn't work. You have to actually be able to know a little bit more about them to help an end user out, because they will definitely be asking you for help. And here's the guy I'm going to ask for help, Mr. Wes Bryan. Wes, when we start talking about printers, this is probably the thing that most IT professionals probably think, it's simple enough, no big deal. But you and I have worked for an organization, the same organization, long enough to know that when printers stop working, people really do hate you.
They really do.
You
You want your printers to work because they can be, much like email, the backbone of what we do from a day-to-day basis. So what we're going to tackle in this episode is we're going to identify some of the basic printer types. We'll talk about some of the components, how they actually print the media, and then some things that we can do when it comes to maintenance.
All right, I'm joking about the hate, but they really don't like it when printers don't work.
Right.
But why don't we head on over to the bench and talk about it more?
All right, everyone, come on over here and join me. And we went ahead and we've got Ronnie's credit card here. Kidding, everybody. We're going to show you some pictures, and we're going to talk about a variety of printer types. And we do have quite a few. Probably one of the most common ones that we have today is this one right here. This is what's known as a laser printer. And a laser printer is, again, one of the more popular type printers. And one of the things that you have to know for your certification exam is a little bit about that laser print process, because it really can help you when it comes to troubleshooting what may or may not be happening appropriately with the printer. So with a laser printer uses something known as a toner cartridge and a bunch of other components to print the output. And I want to take a second here and I want to talk a little bit about the laser printer and its process. So what you have inside of your laser printer is you have what's known as an imaging drum. It's something called, you might hear it called a EP drum. I've heard it called before, an electrostatic photosensitive drum, which means that it responds to an electrical current as well as light. All right, and you have about a 6, maybe 7-step process, if you will, when it comes to the laser print process. And you should be able to identify this for a certification exam, and I would be able to be aware of the process in general, just from a support standpoint. So one of the very first things that happens is you have a formatter board inside of the laser printer, and what that does is it receives the instructions that are processing from the computer. So that's the very first step. It's called processing, and that is just a print job being sent to the printer, and we start to turn it go from a digital image into what we're going to put on a printed media. So that's the very first process. It's called processing. Now, I want you to remember that this is a cyclic process that will constantly keep renewing itself. So if I start with cleaning, you might see some people will put cleaning at the end of the process. Whether it's the beginning, whether it's the end, know the process and the adjacencies of the idea. So once we have processed that print job, next we go into what is known as the cleaning phase. And the cleaning phase is where this EP drum here has all of the charges neutralized on it, and it has any excess toner that is left over, if you will, from the previous print job. But then we go into the charging, all right? Now, the charging is not the neutralization of charges. It's actually the opposite. What happens here is this EP drum has a strong negative charge that is applied to it, right? That's the charging process, if you will. You might also hear it called conditioning as well, too. So a couple different terminology points here. But then we have what's known as exposing, sometimes called writing as well. And if we look at our image here, what's happening is we have a laser assembly and a scanning mirror that is actually bending this light path across this EP drum. And what it's doing is it's actually writing the image to the EP drum. That image, what is happening here is it's actually reducing that strong negative charge on the drum itself. That's the next phase. But then we go in to the developing phase. And the developing phase is as this EP drum turns, we have toner that is attracted to the strong negative charge that's been put on the drum itself. And that's where we see the first signs of the actual image starting to be, come into realization here, if you will. Now, after that developing phase, now we have toner that is loosely adhering to the EP drum. So now what happens? Well, we get into what's known as the transferring phase. And this is interesting because this is where there's actually a strong positive charge that's put on the paper. All right. And as that paper passes under the EP drum, as it turns, the toner that was attracted to the areas that were written to on the EP drum, it's pulled down to the paper. All right, and once it's pulled down to the paper, we get into the final phase. And the final phase is what's known as the fusing process. And the fusing process is where that paper actually goes through two heated rollers that will heat up the paper to around 350 degrees, adhering the toner to the paper. See, a toner is a combination of metals and plastics. Metals, if you will, forming the color. The plastics actually melt, and that's what adheres that toner to the paper. So if you've ever pulled a print job away from a laser printer right after it's printed, and you can feel the warmth of the heat on the paper, that's because that paper has now been heated up to about 350 degrees, and they apply friction and heat to it to adhere that toner finally to the paper. So that's the laser print process, and Ronnie, that's one that I would definitely be aware of.
Yeah, this particular process has actually, been something that can be very helpful when somebody actually pulls a piece of paper out and they run their finger across it, and all of a sudden the toner smears. Well, you know that one of those steps in the process did not actually happen. So that can help guide you to actually figure out what has actually broken down inside, what step of the process may actually be the issue, and then if you actually do have the ability to, you can go in and investigate that. You might find out that you can replace some components. Generally today, of course, they recommend, especially in a business setting, you can get that thing serviced. But overall, though, just kind of realize this is part of that process of learning and understanding what's happening and what particular process has failed there.
Sure, and I want to kind of build on that maintenance conversation because that's one of the things that they expect you to understand. Like, what are some of the things that we have to do as far as maintenance when it comes to a laser printer? Well, one of the great things today is you have to replace toner cartridges. And toner cartridges, a lot of times today, have that EP drum built right into them. So if we do happen to have an EP drum that gets scratched or gets warped, a lot of times you just replace the toner cartridge and that's going to help. But that's not the only thing that you have to replace. Things like the paper and the toner cartridge. Let me show you here too. Right, you do potentially have to implement one of these, and these are what are known as maintenance kits, right? Printer maintenance kits, and there are different types of maintenance kits for the different printer types. But one of the things I'd like to add to this is that sometimes you have to replace things like the paper feed assembly and the rollers, because from time to time they will get worn out like any other moving component, and you need to replace them. So, replacing the toner. Implementing a maintenance kit, something like this, like a printer maintenance kit, doing calibration to make sure your colors are correct, cleaning the excess toner off the printer. Now let's be very, very careful. Toner is a toxic substance, and we do have special vacuums, special filters, and special toner cloths to make sure that you're not breathing any of this in. You do not want to breathe it in. So be very, very mindful that toner is not something that you should be getting on your skin or breathing in. So we have special filtered vacuums, special toner cloths. Wear a mask, wear gloves when you are cleaning or maintaining one of these laser printers.
Right. So, Wes, even though laser printers are probably very prevalent in just about every area in a business, that is not by far the most prevalent that actually goes into the realm of home environments as well. And that's because of the noise and the very fact that it generates heat. There's a lot that actually goes into it. So what about the idea of helping us to understand more about inkjet printers?
The inkjet printer is probably, next to the laser printer, one of the most common printers today. And because of some of the general expense that laser printers can be to maintain, sometimes residential environments, sometimes you're not going to spend the price for a laser printer. So you can get a printer that is a little bit more economical when it comes to price point, and that's something like this. Like, for instance, I got an example of a inkjet printer here. And what an inkjet printer does is it uses a series of cartridges, if you will, and these cartridges have a highly concentrated focused nozzle at the bottom of them that we actually spray the ink onto the paper. So you have ink cartridges, you have a print head assembly that the cartridge is in. Now, let me stop on the print head assembly for here real quick, because you do have inkjet printers that have a fixed print head assembly that is built into the carrier belt that you see here in this image that will pull it back and forth. You do have some of the cheaper inkjet type printers where the print head assembly is in the inkjet cartridge, and every time you replace the cartridge, you're essentially replacing the print head assembly. So pay attention. One of the great things about a fixed print head assembly that's not built into the cartridges is it requires less calibration. However, if the print head assembly fails, it's not going to be just as simple as just removing and replacing the cartridge. So it does have pros and cons. The inkjet cartridge that has the print head assembly, which is most common, built into the cartridge itself, yes, it has its benefits. It does require a little bit more calibration, but if the print head assembly fails, it's as simple as recycling the inkjet cartridge and turning around and buying another one. So in these inkjet printers, you have the ink cartridge, you have the print head, you have what's known as a carrier belt. And that carrier belt pulls the print head assembly back and forth as it goes across the paper. You also have feed assemblies like in every other printer, which has a series of stepper motors that does the paper advance too. These are some things that you may be able to replace and you may not be able to replace. The general maintenance for an inkjet printer is to clean the print heads, and you can do that just by printing. If you just leave it turned off for a long time, the inkjet cartridges will dry out. So one of the things you can do to clean the heads is just print. The other thing you can do is replace the print head, the print cartridges, and you also have to worry about paper jams. So those are some of the things that you need to keep in mind when it comes to just general maintenance around an inkjet-based printer.
Now, there's probably a printer type that we all end up using at some point or another, but don't even realize it because most of us are only on the consumer side of things. But in point of sales machines, we might have those that actually print out like those receipts that are actually very quick to actually print out. And those are thermal types of printers, right?
Most definitely, and they are common in our point of sale systems. And when we talk about a thermal printer, just think of the term thermal. It uses heat to to create the image, and what you have is a heating element that basically strikes a special thermally sensitive paper to produce the colors. Now, typically, what it's going to do is it's going to produce black color. Although there are special papers that they've gotten smart enough with the technology that they can just vary the heat, and they can produce sometimes red and sometimes blue. If you've ever had a receipt that's printed out and it's black, it's got black type, if you will, and then maybe like a little special right there in the middle is red, that's because that paper and that heating element fine-tunes the different temperature variations enough to produce different colors. So one of the things to keep in mind, now let me give you an example here. This is just an example of a standalone. If you've ever paid at the pump and you've gotten a receipt from a gas station pump, that's an example of a thermal printer. Just remember that it uses heating and striking element to produce the output on a special thermal-based paper, which means that When it comes to the maintenance of these components, you do have to replace the paper, just like any other printer. That's nothing new. But you also, from time to time, might have to clean the heating element. Because again, the heating element's using heat, and there will be remnants of the paper that's going to be left on the heating element over time. So you might have to replace or clean the heating element. And another thing that you'll have to do with these from time to time, much like your inkjet printer, is you're going to have to clean the debris that can build up in these as well. So thermal printers using heat and a striking element in order to produce the output, another very popular printer in today's industry.
All right, the other type of printer that we may still also see, maybe in point of sales or just somewhere else, is the idea of the impact printer, right?
Yes, and this is one that you might be saying, man, that's a blast from the past. Why would we have impact printers? It is still the best printer for multi-layer printing that we have. If you've ever gotten a receipt that's got a carbon copy on it, impact printers are still one of the best to do multi-layer printing. So for instance, I've got a line-based, this is an Epson line printer here, and this is one of the more, the faster, if you will, of the impact printers. There's older ones that are kind of obsolete today. They had the old daisy wheel printer, but what we have to be mindful of is that you have a striking element inside of these printers, and you can see this is the old character printer. It was sometimes called a daisy wheel. This is largely obsolete today. I mean, you would have found these on like Apple IIe's to kind of give you a time frame. But what we have here is another striking element as well, and there's a couple of varieties of these. There is a 9-pin variety, and then there is a pin variety that has a lot more than the 9 pins, and that's what's called NLQ, near letter quality printing, that we could do in the impact with the impact printer. So make sure that you are aware that there's a striking element that makes contact to a printing ribbon inside of the impact printer. The other components that you have too inside of these impact printers, you have what are known as tractor feed assemblies. And tractor feed assemblies is just a fancy term for saying this is how the impact printers do paper advance. And you will potentially have special paper that you need to utilize in these that have notches cut out on the side. And again, I know they sound kind of archaic and legacy today, but you do not find better printers even in today's day and age that do multi-carbon copy type printing today. And that's one of the reasons that we still use them, because we're not applying heat. We're not applying an ink, if you will, and that striking element can make contact with all 3 layers in when you're doing your printing. So with maintenance on these, remember, you're going to have to replace the ribbon. The ribbon will run out. That's how the output is printed. The other thing that you might have to do from time to time is actually replace the print head. And then at the end of the day, remember, we also have to replace the paper too.
Now, one of the neat types of printers that have actually kind of come on the scene very strong in the past several years is 3D printers. Tell us a little bit more about that one.
Sure. So for instance, I got an example of a 3D printer up here, and you can find, ladies and gentlemen, you can find all of these images. I encourage you, if you're not familiar with them, these are all Wiki-Common images that you can see for free. This is a 3D printer here, and it's very interesting because it uses filament and resin, and then has what is known as the print bed. And if you've never seen one of these, I encourage you to check one of these out, and they are becoming more and more popular as the price point goes down. If this would have been a discussion about 4 or 5 years ago, we would have been talking about, oh, it's a $3,000, $4,000 printer, and probably only 5 or 6 people have them. But that's not the way it is today. They've definitely come down in price. So just be aware that a 3D printer uses filament and resin to produce the 3D output, and it uses a print bed to actually start to build that 3D image. So 3D printers, amazing technologies. In fact, a lot of these printers are very, very fascinating technologies. They're very, very important in an IT industry today, and being able to identify how they produce the output, what are some of the things that we need to keep in mind when it comes to maintenance, and what are those components that need maintenance and potential replacement. If you can do that, and you can explain it back to me, if you're sitting a certification exam and they put you in a scenario, you should be able to get those answers right. And if you've got somebody calling into the support desk that says, my laser printer isn't printing, you might be able to make a recommendation that, hey, we need to replace the toner cartridge, and at the end of the day, you'll be doing well.
Thank you for watching IT Pro TV.